right? We did before we did adding, right? Factoring. So every time we deal with this stuff, these are, I know that there's another section like in college algebra, especially they do rational expressions, they're called, right? This is the sometimes in a section called rational expressions, and you do like adding, you know, add them together, finding a common denominator, or subtract them, or maybe you have to multiply. Multiply them together, stuff like that. So, but what I'm getting at here is that anytime you do this, you're doing really the same kind of thing you're doing when you're doing fractions. So dividing fractions in some ways is no different. It's just not necessarily what you think, I guess is the best way to say it. I mean, if I had compound things, then yeah. But if I have something like, say I just have something like x squared plus 3x plus 1 divided by, I'll use this symbol that I hate so much, x minus 3, something like that, right? What we're really doing is based on something called the division algorithm. Right? Which looks like this, is that if you take any two integers, b and a, you can write b as equal to a times the quotient plus the remainder, like this. So if I took if I had something like 7/3, this go back to our fraction days, right? Can I write it like this? Sure, I can. You probably did it like this, right? You'd put a 3 here, put a 7 here, it goes in there 2 times with a remainder of 1. And so you would write 7/3 as a mixed fraction, which would be 3 and 2, or 2, sorry, 2 and 1/3, like that. All right, so if I multiply everything by 3, notice that what I get is 7. 2 times 3 plus 1. So here's my, let's see, did I get these backwards? I think I did. I want to go A, B. So, because what we're doing here is we're getting 7 is equal to 2 times 3 plus 1. So 7 is my A. Multiply through by B. This would be B over R. And then, yeah, okay, so it'd be like that. Because this is the same thing we're doing here. Okay, so this is the division algorithm. So we're essentially going to do this stuff right here. We want to write this in terms of something when you divide it out, the quotient, like we have here, plus the remainder. Now remember, this is just a shortcut for this, and that's what we're looking for. Is we're going to rewrite 7, like we write 7/3 as 2 plus 1/3. So that's what we want to do. Now the way we're going to do this is 2 ways. The first way works all the time. The second one is kind of a special case. The first one, we just call it long division, I guess. Right? So let's say I take this one right here, x plus 3x plus 1 divided by x minus 3. This is the problem that I wrote down here, right here, like this. Now, what would I do? So do the same thing I did here. I would take x minus 3 and put this part underneath it. And then I ask myself, what do I multiply x by to get an x squared? Well, all I have to do, of course, is just multiply by x. So if I multiply x by x, I get x squared. And then I multiply x by -3, and I get -3x, like that. So essentially, what this comes from is multiplying x times x minus 3, the distributive property, like that. That's how I got that. Oops, I forgot the squared. So I get that. All right. And now, just like I do back over here, what did we do? We subtracted the 6. So I'm going to subtract. But now make sure that you stick the parentheses on it because you're subtracting the whole term, not just the first thing. So you get x squared minus x squared, which is nothing. That's why we set it up. And then you get 3 minus 3, which is 6x. And then 1 minus nothing is 1. So you get something that looks like that. Now I do it again. I go ask myself, what do I multiply x by to get 6x? Well, I multiply it by a 6. So I get 6x minus 6 times 3 is 18. Now again, I subtract. 6x minus 6x is gone. That's why we set it up. And then I have 1 minus a -18 is 19. So this is my remainder, and that's my quotient, right? So I can rewrite this problem as x plus 6 plus 19 over x minus 3. Just like we did here with this stuff, right? 2, that part, oops, that part right there. And then 1 over the thing I'm dividing. So it's this thing plus this over that. And I'm getting and I'm rewriting it, this quotient, so it looks like that. All right, let's say we do another one. Let's say we have x to the third minus 9 divided by x plus 2, like this. All right, so x cubed minus 9 divided by x plus 2. So what do I multiply by x squared? X times x squared is x cubed. X squared times 2 is plus 2x squared. Now I subtract. So these go away because that's the way it's set up. Then I get nothing minus this. So I get -2x squared plus minus 9. So now I ask myself, what do I have to multiply x by to get -2x squared? Well, I multiply by a -2x. So it's give me -2x squared minus 4x. And then I subtract. And this would give me, well, there's no x's, so this would be 4x minus 9. And I do it again. What do I multiply x by to get 4x? 4. So I get minus x plus 8. And I subtract, and I get -9 minus 8 is -17. So that means that this thing is equal to the numerator, or the quotient, minus 17 over x plus 2, like that. And I get my alternate way of writing it. Now, you don't have, so far I've had linear terms in here. You don't have to have linear terms. I could have like x to the fourth minus 1 divided by x squared plus 2, like this. This would be okay too. What it is, I don't know, but x to the fourth minus 1, x squared plus 2. So what do I multiply x squared by to get x to the fourth? I multiply it by an x squared. So this would give me x to the fourth plus 2x squared. And then I subtract. So this would give me a -2x squared minus 1. Now I multiply this by, because I want equal that to equal that. So multiply by a -2. That gives me 2x squared minus 4. Those subtract off, and this gives me 1 minus -4, which is +4. So that's a 3. So this thing is x squared minus 2x plus 3 over x squared plus 2. Now, how do you know when you stop? Because so far I've had constants, but it's not always constants. It's the way you stop it is once this piece here, the remainder is 1 degree less than whatever you're dividing in, that's when you stop. So let's see if I can come up with one that's not like that. So say I have x squared or x cubed plus 3x squared plus 6x plus 2 divided by, say, x squared plus 2x plus 1, like this. All right, so I don't know what this is, but we'll try it. So now what do I multiply x by to get x cubed? And x. So that'd give me x cubed plus 2x squared plus x, and I subtract. And this is giving me x squared plus 7x plus 2. What do I multiply to get an x squared? 1. So I get an x squared plus 2x plus 1, and I subtract. So this is going to give me, those go away. 7 minus 2 is 5. And then 2 minus 1 is 1. Now, I can't go any lower, so this is I have to stop here because it's 1 degree smaller. So this thing is equal to x plus 1 plus 5x plus 1 all over x squared plus 2x plus 1, like that. So it doesn't have to be, so when you stop is 1 degree smaller. All right, so here's the other way of doing it. And this only works when, let's see, what is this? This is, I always forget these names. Divisor, dividend, remainder, quotient, divisor, dividend. I think that's what it's when. So this only works when the divisor is a linear function ax plus, or x minus h, like this. So it has to have a 1 in front of it, but that's easy to fix up. We'll do some of those. So it has to look like this. You can't divide in degrees, things of higher degree. So that you have to be careful with. All right, so say we have something like x squared plus 2x minus 1, and we want to divide it by x minus 2, like this. So what we're going to do is called synthetic division. Synthetic. Oops, I spelled it. Not spelling. Synthetic division. So what you do is this. You put a little square, half a square here, a little semi-perimeter, and you take this number and you plug it in. Or think of it this way. Whatever the sign is here, you make it the opposite. So since that's a negative, we put a positive here. Now you write down all the coefficients. So you have 1, 2, -1, like that. The first thing is you just write down 1 below the line. Don't have to do anything. Just pull the 1 down. Now the next thing you do is multiply the 2 times the 1 and put it here. Now you add these two, so I get a 4. Pull that one down. 2 times 4 is 8. Add those to get 7. Now, this last one here, that's the remainder. And this is, these are the coefficients of the dividend, divisor, quotient, I don't know, whatever it's called. The thing that, this part here, that thing. So this is, now since this is x squared, and this is x, and that's the constant function, you know, the constant, this would be 1 degree smaller, so that's the x, and that's the constant. So our answer for this thing would be equal to x plus 4 plus 7 over x minus 2, like that. All right, let me try another one. Let's say I have something like x cubed plus 2x squared minus 3x plus 1. Let's say we want to divide it by x minus 1. All right, so I put down the coefficients, 1, 2, -3, 1. I put a little box here with the opposite sign of this one, so that's a 1. So I'm going to pull this down 1, multiplies those together, add them, 3, multiply them 3, I get 0, multiply those, I get 0, add those, you get 1. So since this is x cubed, that's x squared, that's x, that's a constant, the last thing is the remainder, and this is your x squared, your x, and your constant. So this thing is equal to x squared plus 3x plus 1 over x minus 1, like that. All right, let's try this one. Let's say we have something x cubed minus 2 divided by x squared. Oh, you know, let's do it x cubed minus 8. I want it to work out to be something specific. So let's say this is x squared plus 2x plus 4. All right. Oh, I can't. This is long division. Never mind. I want to do synthetic. Let's see. What do I want to do? I will do. Let's do x cubed minus 8 over x minus 2, like this. So I'll show you 2 different ways. The other way to do this. Say I don't realize it's anything. So I'm just going to do synthetic division. So I put a 2 here. And then my coefficients, I put a 1, a 0, and a negative 8. So this is the x cubed term, the x squared coefficient, the x coefficient, and the constant, like that. Because like I probably said along when we first did polynomials, is that they always have some sort of coefficient, even if there's nothing there. You can always put in a 0 for its slot. So I bring the 1 down, multiply, you get 2. Add those together, multiply, you get 4. Add those together, you get 4. Multiply together, you get 8, which is, add those together, you get 0. So the remainder is 0. So that means that when the remainder is 0, that means that this thing divides into it. And so notice that what we have is that's the squared term plus the x term plus the constant. So this thing is equal to x squared plus 2x plus 4, like that. With since the remainder is 0, that is actually a factor, which if we realized it, right, we would have known that the top factor is to x minus 2 times x squared plus 2x plus 4 over x minus 2, and then those just divide out like that. So we're using division in case you don't know what it is, like if you don't remember the perfect cube, the difference of perfect cubes formula, then you can divide it out and still get the answer. All right. So now let's try a little quirk on this thing. So let's say that I have something like 6x squared plus 8x plus 12 and all over. Now let's do this. Let's make it harder. Let's just say I have 6x plus 3x squared plus 7 over 2x minus 4, like this. All right. Now, the one thing I said is this always has to be a 1. Well, when it's a constant, I can fix everything. So if I multiply top and bottom first by a half, this would give me, right, this would give me 3x squared plus 3 halves x plus 7 halves all over x minus 2, like that. So then I can, now I have to work with fractions, but it's possible, right? 3 halves, 7 halves, bring the 3 down, multiply those together, you get 6. 6 is actually, right? 6 is actually 12 halves. Add those together, so you're going to get 15 halves. Multiply those together to get 15, which is really 30 halves. Right? So you get 37 halves. So this says that this thing right here is equal to 3x plus 15 over 2 plus 37 over 2 x minus 2, like that. Which I can then pull the 2 down here and multiply it through and get 3x plus 15 halves plus 37 over 2x minus 4, like that. Get back to the same thing I started with. So that's how you adjust it. You just divide everything by what, get rid of that coefficient by dividing, and then divide it out. Use this one to divide out, and then you can fix it at the end to get back to the beginning if you want.